today we're going to start with our basic steps to solve antiderivatives. First, we're going to start with our a value, which in this case is with the x. And to solve for an antiderivative, you always add 1 to the exponent, and then you always divide it by whatever the exponent is. And at the end, you always have to write plus c, since this is an integral that isn't defined.
Okay, so we're going to start with this simple example, and then we are going to do the antiderivative of this equation. So we're going to take the 7x squared, and we're going to add that by 1. We're going to divide that by 2 plus 1, which will be 3. And then we're going to add the 2, which is going to be 2x. 0 plus 1, 0 plus 1, and the plus c, and the answer ends up being 7x cubed divided by 3 plus 2x plus c. Okay, for our next example, we are going to do an antiderivative with a fractional exponent. So the first step is to take the antiderivative like a normal problem. So it's going to be 4x 3 over 4 plus 4 over 4 because it's the same thing as 1. Then we're going to do 3 over 4 plus 4 over 4. And this leads us to 4x 7 over 4 divided by 7 over 4. And then in this step, we're going to divide this by 4 over 7 because we're going to take the reciprocal. And now we're going to get our final answer, which is 16x 7 over 4 divided by 7 plus c. And don't forget the plus c.
When looking at the integral, and if it is 1 over x dx, or when the derivative of the bottom is on top, the answer will always be ln absolute value, the number of the bottom, plus c. For the next problem, we're going to start by doing u sub of the bottom, which is u equals 7x cubed plus 4x to the 4th plus 5. Then we are going to take the derivative of u, which is du equals 21x squared plus 16x cubed. And since the integral is du over u, then the answer is going to be ln absolute value of the bottom number plus c. These are some trig integrals that you need to know. Make sure you keep on memorizing these throughout the semester. So to start with this example, we're going to start by taking the u sub of tangent. So u equals tangent x. Then we're going to take the derivative of that, which du equals secant squared x. So the integral ends up being du over 2 plus u. And since the derivative is on top, you will do ln absolute value of the bottom, which is 2 plus u plus c, but then you also have to resub the u, which in the final answer it would be ln absolute value of 2 plus tangent x plus c. These equations are some inverse trig functions that you should be able to identify and interpret them as arc problems. In this example, at first glance, it might look confusing, but at a closer look, this integral looks similar to the inverse trig function equations. In the integral, when there is a square root in the bottom, and the order is the number minus the function squared, then that equals the square root of a squared minus u squared, which is identified as an arc sine problem. To start, we can take the 5 out of the integral because it is a constant, and we can just take it out. So it would be 5 with the integral of 1 over the square root of 9 minus 16x squared dx. And since this is an arc sine problem, you would need to find u and a. So a squared equals 9. You square root of 9 which a equals 3. Then you're going to do u squared equals 16x squared. You take the square root of both sides, which is u equals 4x. So now you just need to plug it in to the arcsine formula, which is arcsine of u over a plus c. So the final answer will equal arcsine of 4x over 3 plus c.